Good day, everyone, and welcome to today's DevOps.com webinar. We're excited that you've joined us. Our topic today is innocent vulnerabilities versus malicious backdoors, how to manage your risk. Our webinar is sponsored by WhiteSource. My name is Mitch Ashley. I serve as your host and moderator. A few housekeeping items. We are recording the webinar, and all participants will receive an email with a link to both the recording and a copy of the slides. So sit back and relax. Take a few notes, but don't worry, you'll have the slides in a few minutes. Also, we're giving away 3 $50 Amazon gift cards at the end of the webinar, so stick around to see if you find out if you're one of the lucky winners. I know our speaker today is a great speaker as well as someone who loves to answer questions. So we'd love to have you put any questions that you have into the GoToWebinar control panel right there in the questions tab. So let's move along to our topic, innocent vulnerabilities versus malicious backdoors, how to manage your risk. It's my great pleasure to introduce Rhys Arkins, who's Director of Product Management with WhiteSource. And with that, Rhys, I'm going to turn it over to you. Take it away.
All right, thanks very much, Mitch. Okay, so like I said, innocent vulnerabilities, malicious backdoors, and starting out with a bit of a roundup, comparing them, and then discussing about the different ways in which you can manage the risk of those based upon their attack vectors. Okay, so just first up, this topic of open source and security. So is open source secure? Now this is, the next two slides come from a survey by Red Hat just recently. And what was interesting was that people listed that open source security is one of the barriers to adoption. And this is understandable. We are here today talking about vulnerabilities and malicious activities. So it's understandable that some people would consider security to be a barrier to adoption. You can even see that security rates higher than support. So we sometimes talk about, well, open source, but you don't have support. But people now are concerned about security even more than support. Yet at the same time, those same people answering remark that better security is one of the benefits of open source. So people are a little bit more split. I saw a great quote from one of the product managers at GitHub recently, and he said that open source is not inherently more secure, but it is more securable. And I think that's a really great way of thinking about it, because the code is out in the open. People can look at it if they want to. That itself does not make it more secure, but it certainly enables a greater level of security. So, according to the survey, security of open source is both a barrier to entry as well as a benefit. So let's talk about really what that means. And especially, I want to break that down into two parts. Vulnerabilities, which is a term really, that's kind of like the catch-all term, and a very special type of vulnerability, which is the malicious package or the malicious release. And if you do care about vulnerabilities, you really need to understand the differences between them, because the risk and how you should respond to them are very different. So one of the challenges in with open source today is that the old style supply chain attacks, like the movies, the Ocean's 11, it took a lot of charm and luck and physical risk to be able to compromise a company's supply chain, to be able to kind of get into their process. And that's all changed now. I mean, you still can physically compromise a supply chain, but if we look at a couple of examples in the software area, Equifax is very, very well known. In the Equifax case, their cyber attack affected 143 million people in the US, right? Now, another way of looking at it, I mean, that first one was people's privacy, their social security details and things like that. If we look at a more recent one from, well, very recently, like this year, there was a TravelX hack. It wasn't directly related to open source, but in this case, essentially, they got held for ransom. Their share value pre-coronavirus decreased dramatically. And if you worked out how much that cost the CEO, then he himself lost hundreds of millions of dollars, right? So if we're thinking like, yeah, are companies like White Source exaggerating this or something like that? Well, the reality is that there are hundreds of millions of dollars at stake here if things go to like a worst case. So whether someone is a CEO not wanting to lose their value in a company, or whether we are in development and DevOps, this is a very important problem with very serious consequences. All right, so one of the things though that I do think is a bit misunderstood, I alluded to it earlier, is there is a saying about open source. It's a bit paraphrased, so forgive me, but it came out of Linux originally. Given 1,000 eyes, all bugs are shallow. Now this itself is fairly true, but I think it's misunderstood. The way we misunderstand it today is that many people think that because something is open source, there must be a lot of people looking at it. Now, the reality is that if you've built open source yourself or released open source, you'd probably be aware that there's a lot of lines of code where the only 2 eyes that have ever looked at it are your own, right? So this is changing a little bit thanks to automated tools, but the reality is that just because something is open source doesn't mean there's a lot of people looked at it, does not mean that it is free of vulnerabilities or free of malicious vulnerabilities either. So let's start up with like regular vulnerabilities and talk about the characteristics of those. So, all right, the first really important thing to understand is that a vulnerability, a traditional vulnerability, the ones you probably most have to deal with, the ones you get the most notifications for, it is a mistake. It's an accident. It's an oversight, right? This is not a deliberate thing. And to use the old saying, this is incompetence, not malice, right? So vulnerabilities traditionally don't come out because someone's done something deliberately. It's not really because somebody has taken a shortcut or something like that. It's not like a building collapsing because people use cheap materials. Generally, it's just that people didn't think, or perhaps weren't even aware of the potential of their code. So they may have written code which solves the task they need, completely unaware that it might open up an attack vector because they're just not a security professional, for example. So fundamentally, vulnerabilities are accidents. They are incompetence. All right. So the next thing to understand is that a vulnerability in a package can happen anytime in a package's lifetime. So that the vulnerable code that is discovered in a package, it could actually have been in the initial release, but it also could have been added in a later release. There's no general trend here except for just relating it to lines of code. It can happen at any time. It could have been there from the very start. And if a package had an accidental vulnerability from the start, there was probably nobody looking at it then when that code was being committed. So again, don't overestimate the number of people that might have been reviewing code that you're using. So it's also possible, you're probably familiar, that packages can get multiple vulnerabilities over time. So there can be a vulnerability in 2018, and then there can be another one in 2019. We've even seen cases where essentially the same mistake happens twice in open source packages. So it can happen at any time when the package is created, when it's updated, and it can happen multiple times. All right, so the next point, and this is important to understand with vulnerabilities, is that they may take a long time to discover. Now, if you're working in development or in DevOps and you get a notification about a critical vulnerability, metaphorically, that might seem like somebody threw a flashbang grenade into the room. I mean, it is very, things happen very quickly. But at the same time, don't mistake that the vulnerability itself may be new. And the analogy I use is that vulnerabilities are not like a grenade that got thrown in. They may actually be like an unexploded World War II bomb that only just got discovered. So, it happens a lot in Europe where, a farmer or even someone in a city discovers a bomb in a backyard and it's been there for, 50 plus years. And just like with software vulnerabilities, people need to work out, like, is this live or not? Does it need to come out right away? And even if it's not live, you still want to get rid of it ultimately. And so this is a pretty good analogy for vulnerabilities, because they may be sitting there a very long time. They're discovered one day. It feels sudden to you, but it may have been there a long time. And what you need to be able to do is to assess the risk of it. So you don't know at first, but you can take steps to understand, is this going to affect us or not? So important point, that vulnerabilities can take a very long time to discover. There's even been cases where vulnerabilities have been in code for more than 5 years, very serious vulnerabilities like in OpenSSL. So do not mistake the fact that you just got a notification for the fact that the vulnerability itself may be old. Now, the good news is, when it comes to vulnerabilities in open source software, at least, the fixes for a vulnerability, they usually come before or at the same time as they are disclosed to the public. So what this means is that while it can be quite, concerning that you get a notification of a vulnerability, the good news is there is a fix already. And this is by design. This is not an accident. This is how we want it to work. We want that there is a fix available before you tell everybody about it, because if it is made public that there is the ability to exploit a vulnerability, and yet there is no fix available, this is a very bad situation for everybody to be in. Okay, another important point is that although, vulnerabilities to all of us are, again, quite concerning, the reality is, like, statistically, it's only a small impact percentage normally. So usually only a small percentage of those potentially vulnerable actually experience any harm. And essentially it goes something like this: maybe about 80% of vulnerabilities are what we call ineffective. So you may be told that there is a vulnerability in one of your dependencies, but you also might be told, if you have software in place for this, that that the actual vulnerable code in the dependency is never touched by the code that you call, by the functions you call. So that's what we call ineffective. So maybe ballpark 80-20, 80% of vulnerabilities cannot actually be activated. So those are kind of like the World War II bombs, which are which are not of a threat to you. You still want to get them out, but it's not as urgent as if they are. Now, even from that last 20% where you are using the impacted code, that of course doesn't mean that a malicious attacker could potentially exploit it. And even if they do, it's not easy to find out. I mean, how do they? It may be difficult for them to know if you are even using it or not. So basically, this is why we say that there is a small impact percentage, because if you take the total number of users or the total number of companies who are using packages with a vulnerability, ultimately the number that experience harm, even if they have that version, is pretty low. Now, of course, the challenge is it's not so easy to know if it's you or not. So I'm not saying be complacent. I'm just saying that, factually speaking, a small number come to harm. So the bottom line from all of this is that your regular vulnerabilities, they are manageable. Like, if you follow best practices for vulnerability management, and I will go into that later, the risk of exploitation is usually low. So this is the good news about vulnerabilities. Now, I got a couple of examples here, just to give an example of what I talked about. So, you don't need to care about the number here, but there's an example from 2019 where Kubernetes, hot technology, the API server had a vulnerability. And like with many vulnerabilities, this was improper input validation. That a user could potentially submit some form of input that would not be correctly checked, and then would allow some type of behavior to their liking. So there's a very typical type of vulnerability, which is why I picked it. The person who found the problem disclosed it to the maintainers of the package. They prepared a fix, and in this case they prepared a fix into 4 release streams, which is not particularly normal for open source, because it's not common that an open source project has such great backwards fixing. But they released the fixes, and then once those fixes were ready, remembering, like I said, that generally fixes are released before or coinciding with the announcement, they then disclosed responsibly to their users that there was a problem and that there were patches available, and advised everybody to update. So this is, this is a quite typical vulnerability, and this is how ideally things should be. It is, disclosed responsibly to the maintainers, and then the maintainers can release a fix and then disclose it to everybody else that there is a problem. A similar one here was with Python. This was a native library within Python 2.x. And again, it allowed for attackers to potentially, read local files that they shouldn't be able to through failure to do input validation. Similarly to the Kubernetes one, it was disclosed, it was patched, and then it was announced to everybody that they should update. So this is your classic vulnerability case. If you've got the ability to receive notifications, then you can find out about it. You can be notified, you can take action, and ideally, the chances that you get exploited are very low if you follow these right steps. Okay, so we've covered vulnerabilities. This is the accidental, the incompetence. And like I said, they are mostly manageable. If you have a process in place, you can manage them. I'll talk about the process a little bit later. First, though, I want to talk about the characteristics of malicious packages, because these are very different. And although they're much lower in quantity, you often hear a lot more about them for good reason. So, okay, the first important point, as the opposite to accidental vulnerabilities, malicious exploits in packages are very intentional. These are deliberate, I'll say mistakes or deliberate actions in a code. So that is very different from an accidental vulnerability, where this is, an accident, a mistake, an oversight. Malicious exploits are different because they are done they're done deliberately by the authors. You could think of these as more like a computer virus. There really aren't too many accidental computer viruses. The same thing goes with malicious packages. All right, now again, another difference is that malicious packages, they aim to do immediate harm. So their goal is to get you to run the code, or maybe even just to install it is enough. And once you do, again, like a virus, they want to do immediate harm. Now, that harm can be different things. In the early days, we saw people do malicious packages almost as like a proof of concept because they could. More recently, in the last 12 months, we're seeing a financial aspect come out of it. The Travelex hack, that type of financial motivation. So in nearly all cases, malicious packages are designed to do harm of some sort. It may be silent harm, you don't know it yet, but they're designed to do something bad as soon as they are installed or used. And so this is very different from, accidental vulnerabilities that might exist for years and do no harm. The other difference, they have a very large scale impact. They usually impact the majority of companies or users who've installed it. So, if there was a version or a series of versions that were malicious and you had them, there's a very high chance that something bad, unfortunately, happened to you. And again, this is very different, the opposite of an accidental vulnerability. All right, now another difference is about where malicious packages come in, because generally they are a good package turned bad. It's not very common that someone actually creates a malicious package and then, from version 1.0.0 or 0.0.1, actually tricks people into using a malicious package from the very start. It's possible, it's plausible, but this is not what we've seen, historically. What we see is that a package that, does something useful that people therefore install and use is somehow hijacked it is changed. A new release is made, and that release is the one that we'll call the malicious payload or backdoor is added. So, a package that is good today could be bad tomorrow. That is a key characteristic of malicious packages. All right, so the other thing is that these packages are usually discovered by accident. Now, attackers will usually do their best to cover their tracks. So we see a lot of researchers who will, especially with open source today, researchers will scan open source packages for like common mistakes, common oversights. So that's why we see a lot of vulnerabilities today discovered deliberately, intentionally by, what we call white hat security researchers. But generally what we've found is that the malicious packages, when they do get out into the wild, they've usually been uncovered by someone who's not like a security researcher. They may be security conscious, but they weren't setting out to find it. And that's because, if you're going to make a malicious release, you're normally going to make it non-obvious. So people doing any type of automated scans will not find it. All right. Another really important difference, and this starts, eating into this topic of managing your risk, is that disclosure is usually chaotic. So we talked before about, the regular vulnerabilities and how we talk responsible disclosure and so on. Disclosure is usually chaotic. I mean, if we look at the most well-known ones in the last 12 months, they've been disclosed or made public due to people like tweeting, or people post an issue, to an open source project saying, why is this release got a backdoor in it, and things like that. So as soon as people make a public statement about this malicious release, then we consider that to be disclosed. At least it's publicized. And then, unfortunately, it can be chaotic. On the other hand, it's a little bit different because normally the only person who can exploit it is the original attacker. So there are some reasons to kind of have a chaotic, highly public disclosure, and that's because you do want everybody who's using it to become aware of it. So we literally see when these types of things happen, you might see them written up in ZDNet or the register or things like that. There is no long process here. It is very chaotic. So to take a couple of examples, one of the probably even the most well-known one in the last 12 months was an NPM package called Event Stream. And this shows some of the sophistication. So in this case, a malicious developer, with real developer skills, they added real fixes to an existing package and then volunteered to take over maintaining the package permanently. And this package was in heavy use. Its original author wasn't using it anymore. And he was very happy that someone else who did use it wanted to maintain it. It's open source, so he gave that person rights to do the maintenance. Now, soon after, that developer added a dependency on his own malicious package. The way he did it's not too important here. The key point was that he made legitimate fixes and releases before making a malicious release. Now, this one was installed very, very widely. You could say the fortunate thing for many companies was that this package actually had a very narrow range. It was deliberately targeting Bitcoin users who are using a certain open source wallet. So it was a very, very targeted attack. So a lot of people installed this malicious package, and at first nobody knew even what it was doing. If you look in the screenshot, you can see that there's, it's encoded. It turns out what it was doing was looking for people who were running the Bitcoin wallet and then would unfortunately, steal their Bitcoin, as I said. So this one was very serious, and it actually made millions of dollars from unfortunate users who were multiple steps down the open source chain. Now, it's not just limited to JavaScript. There was a popular Ruby package called Bootstrap Sass. Now, in this case, the attacker actually essentially hacked or took over the publish rights of a legitimate developer. We've seen this happen in different ways. So, for example, if a developer has reused the same email and password in different systems, and one system gets compromised and disclosed, people will say scan, Ruby gems and npm.js and look for people using the same login. If they find that, they then look at what packages they own and they can attack that way. So basically, a new version was released. It added a backdoor to the code. And one clever bit was that that code would phone home to its owner only if it was in production. So it meant that you could install this package, you could test it, and you wouldn't notice that it was trying to make any new connections or anything like that, even if you were very security conscious. So this happened in the Ruby ecosystem as well. So two examples of malicious packages. So now let's compare and contrast vulnerable and malicious. Vulnerable are unintentional, malicious are intentional. Vulnerable are usually difficult to exploit, whereas malicious are designed to exploit immediately. Vulnerable packages are hopefully disclosed gracefully, whereas malicious packages are nearly always disclosed chaotically. We see a much higher volume of vulnerable packages than we do malicious packages. And again, generally speaking, vulnerable packages are rarely exploited from a raw percent point of view when you compare the number of people who are, we'll say infected, if I can use that term, whereas malicious packages might be successful exploiting nearly everybody who was unfortunate enough to install the update that had the bad code. All right, so they're very, very different. Although you might see people use the same term, and even say I at times will just bundle these together in this concept of vulnerabilities. The reality is that a malicious package is a very, very different and more risky form of vulnerable package than your common accidental vulnerability. So let's look at, first of all, malicious dependencies and managing the risk. So you understand that malicious packages exist. Tell me how do I minimize my risk? Now, unfortunately, it's a little bit like viruses. There's only so much you can do. You might still be vulnerable to them. So let's look at what's possible. So if you look at the basic, well, sorry, I should say this. I'm just kind of doing a mock here of here is how someone will attack you. So the basic approach is you would say steal somebody's credentials. You would publish a malicious release. But you wouldn't be able to actually change the source code because you don't have the GitHub credentials as well. So we've seen this a lot. Generally what happens is people will notice that there's a release on NPM or on RubyGems or Maven Central, and that there's no release, there's no tag on GitHub, and then they'll look into why, and that's how people generally accidentally discover it. So this type of attack is very basic, and it gets taken down pretty quickly. Now, the advanced approach, and I kind of discussed it before, is that if you're the maintainer of a package people use, you could do the following. You could publish a bug fix to GitHub. So you have a new commit, it fixes a problem, it has a tag, but you could then go and publish that fix combined with a malicious payload to npm.js or RubyGems. Now, if you do it that sophisticatedly, then you might wait months or longer to be detected, because it's pretty hard for people to actually notice that has happened. The reason why is because when you see the source code links on npm.js or on RubyGems, or frankly anywhere, those URLs are supplied by the author. So if the author is malicious, they can say, yeah, the source is on GitHub, but it maybe isn't. Right? There's actually no enforced link between source code and an artifact. All right. So the problem is nobody has the time to review all the open source packages they use. Everybody assumes that if there was a problem, somebody else would have noticed it. So even though you don't have time, people tend to assume that somebody else does. Even if you did read the source code to a malicious package, the sophisticated attacker wouldn't put their bad code, their exploit, in the source on GitHub. They would actually just publish it to the artifact. So you're looking in the wrong place anyway. If you attempted to download and read the actual artifact code, it may be so transformed and built that it's nearly impossible for you to find or notice the exploit anyway. All right. So, and then the final problem is that most package managers are designed to propagate new releases as quickly as possible. So by design, most package managers think, that you do want the latest version, and they do their best to give that to you. So the challenge is, once those malicious packages are released, they start propagating kind of automatically. You're not necessarily opting into it, it's just happening, right? And the problem for this is essentially semantic versioning. This is this idea of, you use a breaking version for major and everything else should be compatible. So the concept is great. We say all releases within a major version should be backwards compatible. This is a great idea. The mistake is to declare your dependencies as dependent on any version 1.x. Because if you know version 1.x should be compatible, you think, yeah, I'll use any version 1.x. It's like an automatic upgrade. So the problem is, as soon as there is a malicious 1.x, you've got it, because you said use any 1.x. The result of this is that any time a package manager needs to choose what to install, it will pick the absolute latest version that's compatible, even if that version is minutes old. Even if it includes an exploit, you've got it, if you're unlucky. All right. So, okay, now what can be done? All right. So one of the most important things you can do is to pin your third-party dependencies to exact versions. So for open source that you depend on, do not just say 1.x unless, well, if you have a reason for it, you'll know it. Otherwise, pin it. Now, if available, use a lock file to freeze your dependencies in place, meaning that you don't just automatically, 1 minute after a package is released, get it the next time you install. Your lock file will stop you from getting it. And then finally, you should perform upgrades intentionally, not just kind of invisibly or automatically. All right, so that's malicious packages and how to minimize the risk there. The good news is we're going into vulnerable packages now and how to minimize those. And this is one of the ones where the risk is manageable, like I said. So the first thing, the fundamental thing with managing open source vulnerability risk is you need to know what you're using. If you are using open source in a company to build your website, or even worse, to build your own product, and you can't answer the question of exactly what are we using in each release, then you're going to have a problem. You really need to know what you're using. And the only way to do that is to do it with automated scans. You got somebody doing a spreadsheet or a Google Doc or something, you're never going to keep up. So you need automatic scans to build inventory lists. A really quick and useful way to do that is just to look at the package manifests. So, if you just look at package files and you consider them to be a source of truth, it's a very quick way to get a software manifest, but it's not 100% accurate or guaranteed way. The most thorough way to have a software manifest is source file and build scanning. And what that means is that you want to run essentially a fingerprinting of all the files in your build to match them against known open source files, and then use that to build up the bill of materials for your software. This is the only way to know that you're not missing something, is that you literally scan every file that got pulled into your build, you compare it against a known list of files, and then whatever is the overlap is the open source that you're using, right? So this is how to know what you're using. If you use package manifests, you've got a good idea. If you use file scanning, you've got a great idea. The number 2 rule then, once you know what you're using, is you need automated vulnerability notification. Don't wait to kind of run, npm install and look and see if it tells you now you've got a vulnerability. What you want is to be notified immediately that there is a vulnerability affecting your code. Now, these new notifications could be because of one or two things. It could be a recently disclosed vulnerability. This is the most common. So, like with Kubernetes or something. The vulnerability is being discovered, it's cross-checked against your software that you're using, and then you're notified. Something that is much less common, but people are pretty concerned about it nonetheless, is you may potentially introduce a known vulnerability into a repository that didn't have vulnerabilities. It is possible that developers could, say, introduce a new dependency into a software build, and that new dependency is vulnerable for the version that they used. It's not common, but it's possible. You ideally do want to block that though. So then the next question is, who needs to be notified and how? You've got developers, you've got DevOps, you've got security teams. Well, the answer is ideally everybody. And the next part is notify them where they live. So don't have just a dedicated security portal and tell your developers and DevOps, hey, you need to like keep a tab open there every day. Ideally, if your developers or DevOps, if they live in GitHub or GitLab or they live in Jira, you want to notify them there. So, if you want people to be responsible for the security, notify them where they normally do their work. Email, Slack, etc. So the answer to the above is all of the above. Notify everybody and notify them in the ways that they want to be notified. All right, step number 3. So step 1, we know what we're using. Step 2, we have an automated way of being notified if what we're using is vulnerable. Step 3 is to prioritize and triage. So for example, the first question you can ask, and ideally this is one that you could in fact handle automatically. This could be automatic triage based on a project by project basis, is, are these dependencies in customer facing applications? So if you have some kind of user input validation vulnerability in your code, there is a huge difference between whether that's running on your website that might have access to customer data versus if it's just like an internal tool, like a time tracking application or something like that. So there's a very order of magnitude different risk between if it's customer facing or not. And so ideally you can triage that automatically. Now the second step is, are they exploitable? So when the description says that a user could submit a regular expression that could cause a DDoS overload attack, if you look at that and you think, well, I don't let users submit regular expressions anyway. Like our regular expressions are all internal, they are not user controlled, then that actually says that this vulnerability is not exploitable. And then the final step is, do you even use the code that's vulnerable? Now, it's quite often that developers are kind of told we have like a high or critical severity issue, and their answer comes back saying, yeah, but we're not even using that code. This is like, I just wasted, my morning, why did you bother me with this? If you constantly alert developers about vulnerabilities in areas of code that they're not even used, unfortunately, that leads to them to, it's like crying wolf. It leads to them to kind of have a negative attitude about security vulnerabilities and maybe not take them as seriously. So the ideal here, and this is something at White Source we support, is an automatic detection of whether vulnerable code is used by your code. So do you call any of the functions that run the code that was vulnerable? And what we have found is that actually about 80% of our users, 80% of the vulnerabilities, I should say, for our users are not effective, meaning that even though there is a vulnerability, there is a World War II bomb in that backyard, it is not live. It cannot be touched. Now, you should still take it out, but it makes a very big difference towards how you handle that and how you handle the risk internally. Okay, and then the fourth point. All right, so we know what we have. We're notified automatically if it's vulnerable. It is prioritized, ideally automatically, if it is actually, a risk or not. So the fourth point is you need to remediate, right? You need to get rid of it. So there's 3 options for remediation. You can update to a non-vulnerable version. This is the normal step because, like I said, most vulnerabilities come with a patch already. So there is a fixed in version, and it's very clear. Update to that version to remediate the vulnerability. Now, a second option can be, but it's rarer, that you can roll back to a non-vulnerable version. This is more common with the malicious types because often the malicious one is the last released, so you just want to roll back to the previous one. It's not very common in vulnerabilities, regular ones, that that a vulnerability got introduced in a particular version that you were using, and you could just roll back to a previous version and not need any of the new features or fixes that are in that newer one. So rolling back is much rarer than rolling forward. The third option is to remove the dependency altogether. And in fact, I see this happen more than I see rolling back. So this is a case where if a company gets too far behind, they might have a dependency that's 1 or 2 years out of date, and then they get told that that it has a vulnerability and you have to upgrade 2 years worth of code. Some may actually choose to rewrite their code to not use the library rather than have to manage the upgrade. So these are the 3 approaches that you have. And then of course you need to deploy that change into production as well. All right. Now the last step, prevent and prepare. I mean, this one, it feels like the optional step, but this is the one that pays itself off dramatically compared to the others. So look, a significant percentage of vulnerabilities are fixed discreetly before they are disclosed. All right. And what that means is that, if you have any kind of automated process to update packages regularly, and we have a tool, white source called Renovate, that does it. So if you've got a process to automatically update, you can often stay ahead of many vulnerabilities. So there might be a vulnerability that everyone's worried about, but you're not, because through luck and good planning or preparation, you may have already taken that new version last sprint, and you didn't realize at the time that it was actually a vulnerability patch. It just looked like a bug patch, but you took it, you have a process to take it, and therefore you were not vulnerable to it at the time of disclosure. Now, that's nice, and it happens sometimes, but not always. If you regularly update, you can't be guaranteed that you'll never be caught out. But if you are affected by a vulnerability, it's significantly more easy to remediate it if you are already up to date, or nearly up to date, I should say. So you imagine, you are 1 year behind, 1 major release behind, 8 feature releases behind. Compare that to if you were just like 1 sprint behind, if there was just like a couple of patches since the last time you upgraded. Now, in that case, if you're told that you have to upgrade to the latest and the only diff is a couple of very simple bug fixes, that's really easy. You can solve that right away. You can deploy that to production. If instead you've got to upgrade a major release, review the release notes of 8 feature releases, I mean, that's going to take you a lot of time, or it's going to take you a lot of risk if you don't spend the time. So even if you only care about vulnerabilities, being relatively up to date is a very good strategy to make the problems much less. It's like exercise. Like if you're fit, it doesn't guarantee you won't get a heart attack, but it pretty much guarantees that you've got a better chance of surviving it if you're unfortunate enough to get it. So if possible, or it is possible, you can automate that. And so this one is a very effective approach to minimizing the impacts of vulnerabilities, and you can automate that. It's very simple, and you're probably not only going to make yourself safer, but you're probably going to save your developers time if they were already doing upgrades manually until now. All right, so those are the 5 steps to protect yourself from vulnerable packages. Okay, so Mitch, that's the last slide. I think we're right on time.
Yeah, doing well.
Thanks.
Great.
I'm going to take a sip of water. Could you see if we have any questions?
Oh, absolutely. Yeah, a much deserved sip of water. Rhys, go for it here. So while you're doing that, let's look at our first question. So first question from the audience is, do you think malicious vulnerabilities should always be classified at the highest risk level?
Okay. Yeah, so should malicious packages then be a high risk level? So if you're familiar with the way vulnerabilities work, we generally have these classification levels, low, medium, high, critical. We have scoring out of 10. So yeah, generally, yes. I mean, malicious packages, because their intention is to do harm, because their exploitability capability is very, very high, I think that there should basically nearly always be rated as a 9+ out of 10 or a critical level. These are the ones that, if you have them in your system, whatever your threshold is for alerting, yes or no, you want the pages to go off if you've got malicious. So yeah, I would answer yes. And I think that's what you'll generally find as well. If you went back and studied the CVEs, I think you'll see them rated high 9s, if not 10s, just because, you know, these are a problem if you get them.
Okay, great. Let's look at next questions come in is, do you think there are likely open source packages in use today that contain malicious code? That sounds like a softball question there for you, Rhys.
Well,
Somebody
yeah,
likes you.
well, I didn't actually, yeah, well, I didn't, yeah, I probably should have covered that one though. Well, this one maybe is a little bit more deeper than you think, because so I talked about all the ones we caught. So this is, you know, this is like the question, do you think there are serial killers out there, right? I mean, because you always see TV shows, you know, all the serial killers have got caught or whatever. And actually, you know, the police who are in charge of it, they kind of say that, like, we don't always know that there's a pattern. There actually may be, there's, you know. So in this case, the question is, are there malicious packages potentially stealing our Bitcoin? Probably not for that, because people would notice it. But are there ones that are maybe there are packages on our public registries with open backdoors into, you know, the Fortune 5000s of the world? I think almost certainly yes.
Mhm.
Almost certainly yes. There are packages that we haven't caught, that nobody has stumbled over. You know, I had the slide about how a sophisticated attacker would write a malicious package, you know, where you're the author, you make a legitimate looking patch to the source code, you combine it with a malicious payload. I think there's probably at least one case where someone has very successfully done this. Yeah, I guess that's the bad news answer. But yes, I think that there are malicious packages out there today, probably extracting massive databases of data, and we haven't found them yet.
Well, and I think your earlier point during your talk, you were talking about the lifespan of code. Doesn't, when you find a vulnerability or a malicious package, malicious code, doesn't mean that's the one time it'll ever happen. Could happen over the life of code. Someone got into the CVS or GitHub or whatever and launched in some code that's going to live with it for a while. So what's safe today may not be safe tomorrow, right?
Yeah, exactly. So that's one of the key things, is that, you know, something that has always been safe maybe has a problem tomorrow. Something that you fixed last year, you know, that doesn't mean it's kind of fixed forever. I mean, we're all human. Bugs can be introduced again. Actually, something though on that topic that I find interesting is with GitHub Security Lab. They are they're doing their best to let researchers basically find common mistakes and automatically scan for them, so that you ideally, you know, if your package does have problems multiple times, at least they shouldn't be the same problem. And if someone else has, you know, made a mistake, you hopefully get saved from making that same mistake in your package.
Well, exactly. Okay, great. The next question that's come in is, what about accidental looking vulnerabilities?
Yeah, okay. That's actually like, that's like this kind of this really good overlap between the two topics. Well, at least if they're asking what I think they are. So what about accidental looking malicious? Or yeah, so in fact, that would be the absolute super advanced attack. You know, it could have been another slide there. This is where I mean, because, you know, we know from looking at vulnerabilities that oopsies, one little equals sign mistake, or you know, one extra check for not null, and wow, people can get into the server and extract out and things like that, right? Buffer overflows, things like that. So that idea is one where, like, a really sophisticated attacker would insert that type of accidental mistake into a package, and it's so, you know, it's so good at its accidentalness that people don't notice it. This is definitely another possibility. There is a Chinese tech company that has received some sanctions by the US in the last year, who, you know, denies it vehemently that they have any backdoors or anything. And I've seen people claim though that, you know, that their strategy, you know, their code is so buggy that they believe it to be deliberate, you know, that the accidents are actually deliberate accidents. So I of course don't know if that's true or not. But those types of allegations have been raised. Nobody's been caught out doing that yet. So, if people have done that, put deliberate, accidental looking vulnerabilities, then nobody's been thought of to be guilty so far.
So not a prevalent technique, at least that we know today then.
Yeah, exactly. There's been none of the accidents. There's been accidents that people have found, but no one's looked at that and thought it's a suspicious looking accident. Not to my knowledge.
To this topic, just to keep the thought going a little bit, question for you. It seems like if someone's going to implement malicious code, the less sophisticated that it looks, meaning the less likely it's going to stand out, the better, right? So if you can do something
exactly.
that's easy, that looks sort of like the pattern of how things normally work, great. You might overlook that that's actually malicious code.
Yeah, exactly. So, there's ones that have been found, again, by accident, where the second you look at the code, there's a screenshot in one of my slides. The second you look at it, that looks sketchy. But one that is just a run-of-the-mill accident, that's much harder. The only thing is that the security industry is getting much better. I shouldn't say much better. There's more people are building great tools and great automation that enable people to scan the entire GitHub source code registry. So if you made your mistake too vanilla, it might get found by one of the many automated checks that people have. So yeah, that would be, I would say, to do that and get away with it would be an extreme level of capability, but I have no doubt that people could do it.
Somebody's probably good enough to fake it, make it look fake.
Yeah.
Next question. I'm sorry, go ahead, Rhys.
Yeah, actually, I saw one coming in. I wanted to add to that. What sort of public services can be used to scan your stuff? Yeah, so I want to answer this because we at WhiteSource we have a couple of free tools to do this. So we have one tool called Renovate, and that one will do your automatic updating of code, which, like I said, can kind of patch your vulnerabilities, by luck sometimes. And we combine that with another tool called Bolt. So if you search for WhiteSource Bolt, then you can find a free tool that lets you scan for vulnerabilities that way.
Okay, interesting.
Sorry,
great.
Did you have another one?
No, I think that was our last question that we had come in. So great job. Yep, here's the thanks from Niels. Oh, we do have one more question. Do you see that one there about the main trends of malicious packages?
Yeah, I saw the same. Okay. What are the main trends of malicious packages these days besides Corona? Financial attacks, social attacks. Yeah, so I kind of alluded to a little bit before. We've seen a shift from, in the early stages, a lot of people thought, wow, it would be so easy just to do this, and they did it. And also some of the early people made a lot of mistakes where they got the code in, they had lots of people using it, but the one line they added, to read the password file and send it to a web server, believe it or not, didn't work. We've been saved by that. The more recent ones have been much more sophisticated and much more financially motivated. So people playing a real long game, we've seen people write a package that was related to, I'll say crypto, like Bitcoin crypto. They deliberately wrote a package that would be useful to people so that they could put a backdoor into it later, because they knew that their target market would be someone they want to attack. So definitely the big difference is, people have learned from the mistakes of the early ones, and the attacks these days are financially motivated, that they're really targeting money. They're not so much interested, in an email database. They are going for how could I, within 1 or 2 steps from this backdoor, how could I get money? So yeah, definitely the finance industry is like a primary target for that.
Well, and folks who are doing the attacking often sell what they get to others who are attacking, like password files and personal information.
We're seeing that's becoming almost a commodity in itself now, though. There's so many leaked user databases that the same email addresses and names show up 8 times. So there's still some value in it, But yeah, we're seeing that people put the effort in now for like, credit cards and Bitcoin rather than so much like email addresses and user data.
Great. Well, we thank Maya for that question. Looks like that's our last that we've had come in. So great job on your presentation, Rhys, and answers to the questions. As very informative and helpful. So let's jump to a little bit of housekeeping here. We have 3 gift cards that we're going to give away, Amazon gift cards for $50, and that goes to Eric H, Lena K, and Zach W. So the folks at MediaOps will get a hold of you to get those cards to you. So just a reminder, we are sending an email to everyone that registered for this webinar with a link to the recording as well as the slides. And you can also check out DevOps.com. The replay of that will be available there as well. So the other great content for other webinars is up there. So please thank me in joining Rhys Arkins, who's Director of Product Management with WhiteSource. And of course, thank WhiteSource for sponsoring today's webinar. I'd like to thank you, our audience. You've spent pretty much an hour with us today. Your time's extremely valuable, and we're honored that you would spend it with us. Thank you for doing that. It's been my pleasure hosting the webinar today. And have a great day and be careful out there.